Determine whether the given function is linear or nonlinear. If it is linear, determine the equation that defines y equals f of x. Here we have a chart describing our function. The x-coordinates are as follows: -2, -1, 0, 1, 2. The corresponding y-coordinates are 12, 7, 2, -3, and -8. To determine if this function is linear or nonlinear, we begin by calculating the average rate of change, or delta y over delta x, between consecutive data points. We will use the slope formula y sub 2 minus y sub 1 all over x sub 2 minus x sub 1 to calculate this average rate of change. So for our first two data points, we would have 7 minus 12 divided by -1 minus -2. Simplifying this fraction, we have -5 over -1 minus -2 is +1. This results in an average rate of change of -5. We continue this process looking at every pair of consecutive data points. Let's look at the second and third data point. Using slope formula, we would have 2 minus 7 divided by 0 minus -1. This fraction simplified results in -5 over 0 minus -1 is +1, again resulting in -5, the same average rate of change as we calculated with the first set of data points. Continuing with this process, we would find that between every set of consecutive data points, the average rate of change will always be -5. So due to the average rate of change being constant, this will be a linear function. Now that we know that our function is linear, we can now find the equation that defines y equals f of x. Again, since we know the function is now linear, we can use the point slope formula y minus y sub 1 equals m times the quantity x minus x sub 1 to find the equation of our linear function f of x. We've concluded that the average rate of change is equal to -5. Therefore, slope m will equal -5. From our list of values, we can use x sub 1 equals -2 and y sub 1 equals 12. Making those substitutions into our point slope formula will yield y minus y sub 1 is equal to 12, and that is equal to slope m, which is -5, times the quantity x minus x sub 1, which equaled -2. Next, we will simplify our parentheses. X minus -2 will give us x plus 2. Next, we use the distributive property with our -5, giving us y minus 12 is equal to -5x minus 10. And next, we add 12 to both sides of the equation, giving us y is equal to -5x plus 2. Therefore, the equation that defines y equals f of x is y equals -5x plus 2, which could also be written as f of x is equal to -5x plus 2.